Hi, I'm Mark from GCode Tutor and welcome to the final lesson in this course on how to program a bush on a CNC lathe. So the previous 5 lessons we've made the bore, we've finished turned, we've rough turned, we have drilled, we have center drilled our part. All it's left to do is part off. So in this lesson we're going to look at how we're going to part off our bush program here to make our complete part. So by now I'm sure you're getting very familiar with how I lay out my programs. So as you've seen before, we're going to start off with a search number and an operator's note, and I start off all my sequences this way. So the operator's notes I've kept very simple, it just says part off, but we can add information about our tooling and grade of tips in here also. The safety line we've seen many times before also, and this puts the machine into a safe state so we can run the rest of this sequence without worrying about cutter compensation or cycles being active during this sequence. So next up is our tool call. So we call our tool with TO6 because we put our parting off tool into position 6 of our tool turret, and the second 06 there calls upon our offsets that's stored in the offset table on the machine controls. And MO6 gives the command to rotate the turret, so tool 6 is at X0, it's at our cutting side of our turret, so we're ready to start cutting material. But before we start cutting, we need to set our spindle RPMs. And because we are changing diameters with this tool, as we come in closer to the center line, the spindle is going to speed up. So we're going to be using constant surface cutting speed. So before we do that, we have to add a speed clamp. Now this is a command that tells the machine not to rotate the spindle above this set RPM. So G50 is our spindle clamp G-code. This tells the machine never to exceed 2400 RPM that we set with the S word next to the G code there. So G96 is our constant surface spindle speed command. So we use G96 and not G97 when we're doing CSS cutting. Now, as you might know, CSS is generally referred to as constant surface speed. So we're setting a constant surface cutting speed of 220, and MO3 is the direction we wish to turn our spindle on. Now if our tools are back facing, we would be using MO4 here, so just be aware of that. With our spindle rotating, we can now safely move our tool around to its initial cutting position. So if you remember, our stock bar size was 60mm, so I'm coming up in X to 65mm. So to the right of our part here, we still have that 65mm diameter stock bar. Now Z-40 is the length of the job. Now this is assuming that we've set our 0 position on the tool to the right of the tip. If it was to the left of the tip, we would have to add the width of our parting off tool to this movement. But I've set my right hand side of my tip to 0 on the tool position, so Z-40 would remove it exactly 40mm. So in this example, I'm just using point-to-point parting off. Now we can use a grooving cycle for this operation also. Now a grooving cycle would remove a bit of material and then wrap it away. It works a little bit like a drilling cycle in that respect. But depending on the material, we don't generally need to use a grooving cycle to part it off with. But the option is there if we have a material that keeps melting and binding on the tip, for example, or if we have an extra hard material that might need a little bit of help to stop that tool from breaking as we're parting off. So to part off our bush using single point programming, we're using G01, our feed rate command, and then X minus 0.3 because we just want to come just past the center line. Now we're parting off into a bore, so this is less important, but normally we want to part off just past the center line so we don't leave a pip. Of course, if your tool is not on center, you're going to leave a pip anyway. And then we finish off this block by issuing a feed rate with an F word. So at this point, our part is now parted off and it's lying in the bottom of the machine. If you have a part catcher on your lathe, then you would issue the M code that triggers the part catcher to catch this. Now sometimes we could do that by coming down to say X 22mm, then on a separate line bring out the part catcher and then continue parting off the rest of our parts down to X minus 0.3. This way the part catcher would activate just before the part is parted off and not activated right at the beginning of our parting off sequence, adding extra collision items inside the machine. So once our part is separated from the stock material, we can rapid our tool away to a safe distance. So G00 our rapid travel command, and I'm coming up to the stock bar size diameter plus a little bit to give us some clearance with X 65mm. By stating Z5 here, we're moving our tool 5mm past the front face of the component. So this gives us clearance from anything that's inside the machine regarding our materials. Now, the reason I've done this on 2 lines is if our parting off failed, say our tip broke and the part didn't part off, we still wish to move in X first and then Z so we don't collide the tool with the failed parting off material. So with the tool in a safe position, we can now switch over to our machine datum with G53 and take our tool home. So X0Z-210 will take our tool back to its tool change position. And if you're curious why I'm using Z210 and not Z0.0 here, look back for the previous lessons in this series and I explain more there. So finally, MO9 would turn off our coolant. Now, because we were using constant surface cutting speed and not revs per minute to control our spindle speed, we have to turn that back to revs per minute. I always like to go back to defaults during the sequence so we don't have any nasty surprises further down the program, especially if we've skipped any sequences. So G97 puts us back to revs per minute and MO5 will turn off the spindle. Now, some of the older FANUC control systems only allow us to have 1 M code per line. So that's why the following part of this sequence, I have my M codes on separate lines. So like all my sequences, I end with an optional stop, MO1. And this gives us the ability to stop the machine if we require and check our part. Or in this case, we would stop the machine and fish our part from the bottom of the machine if we don't have a part catcher. And if we didn't have a part catcher, we would use M00 here to make sure the machine stops so we could retrieve our part. So that brings us to the end of not just this lesson, but the complete series on how to make a bush on a CNC lathe. So if you've not seen the previous lessons, I would recommend jumping back and starting from part 1 of our bush program and watching through all 6 lessons of this series. Now, if you enjoyed my style of teaching and you feel you could learn a lot about programming G-code from me, head over to my website, gcodetutor.com, where I have 12 courses currently that teach you how to program CNC machines in a variety of ways. We also have maths courses and CAD/CAM courses, as well as my standard professional level G-code programming series I have on there. So head over to gcodetutor.com to continue your learning of G-code.